Hello everyone, welcome to new class. Today's class is about the continuation of basics of power systems. So in the previous class we have discussed about the single line diagram of power systems, and let us discuss about the important terms and factors in power systems. First one is connected load. It is the sum of continuous ratings of all the equipments connected to the supply system. So connected load is the sum of continuous ratings of all the equipments connected to the supply system. So a power station supplies load to the thousands of consumers. So we know a power station supplies load to thousands of consumers, and each consumer has certain equipment installed in his premises, and the sum of the continuous ratings of all the equipments in consumers premises is the connected load of the consumer. So consumer has several equipments or loads connected to the consumer, and the sum of continuous ratings of all the equipments in the consumer's premises is the connected load of that consumer, and the sum of the connected loads of all the consumers is the connected load to the power station. For example, if a consumer has connections of 500 watts lamp and a power point of 500 watt, then connected load of that particular consumer is 5 into 100 plus 500, that is equal to 1000 watts. So this is about a single consumer, and the sum of the connected loads of all the consumers is the connected load to the power station. So that is about the connected load. Then next term is maximum demand. So what is maximum demand? It is the greatest demand of load on the power station during a given period. That is, the load on the power station varies from time to time. So load varies from time to time in a power station, and the maximum of all the demands that have occurred during a given period, say a day, is the maximum demand. So a power station has several loads, and the maximum of all the demands that have occurred during a given period is the maximum demand. And the maximum demand is generally less than the connected load. So maximum demand is less than the connected load, because all the consumers do not switch on their connected load to the system at a time. And the knowledge of maximum demand is very important, as it helps in determining the installed capacity of the station, and the station must be capable of meeting the maximum demand. Next is demand factor. It is the ratio of maximum demand on the power station to its connected load, and the value of the demand factor is usually less than 1. It is expected because the maximum demand on the power station is generally less than connected load. For example, if the maximum demand is 80 megawatt and connected load is say 100 megawatt, then the demand factor will be equal to 80 divided by 100, that is 0.8. And the knowledge of demand factor is vital in determining the capacity of plant equipment. Then next one is average load. The average of loads occurring on the power station in a given period, day, month or year, is called average load or average demand. So daily average load is number of units generated in a day divided by 24 hours. And monthly average load is number of units generated in a month divided by number of hours in a month. And yearly average load is number of units generated in a year divided by 8760 hours. So that is about the average load. Next term is load factor. It is the ratio of average load to the maximum demand during a given period. So it is the ratio of average load to the maximum demand during a given period. So if the plant is in operation for T hours, then load factor is equal to average load into T divided by maximum demand into T. And average load into T is the number of units generated in T hours, because average load is equal to number of units generated divided by time. So average load into time is equal to units generated in T hours divided by maximum demand into T hours. So the load factor may be daily load factor, monthly load factor or annual load factor. So it is also daily or monthly or yearly load factor if the time period considered is a day, month or year. So if the time period considered is a day, it is called a daily load factor, and if it is monthly, then monthly load factor, and if it is considered as year, then it is called yearly load factor. And this load factor is always less than 1 because the average load is smaller than the maximum demand. So average load is less than the maximum demand. So load factor is less than unity. And the load factor plays key role in determining the overall cost per unit generated. Cost per unit generated. And higher the load factor of the power station, lesser will be the cost per unit. So higher the load factor of the power station, lesser will be the cost per unit generated. So that is about the load factor. Next is diversity factor. The ratio of sum of individual maximum demands to the maximum demand on the power station is known as the diversity factor. So a power station supplies load to various consumers, and these consumers' maximum demands generally do not occur at the same time. So each consumer's maximum demand do not occur at the same time. Therefore, the maximum demand on the power station is always less than the sum of individual maximum demands of the consumers. So, power station has a maximum demand, and also the consumers, different consumers have maximum demands, and the sum of individual maximum demands, that is the sum of the maximum demands of the consumers, is always greater than the maximum demand on the power station. So this numerator is greater than the denominator. So the diversity factor is always greater than 1, and greater the diversity factor, lesser is the cost of generation of power. So greater the diversity factor, lesser is the cost of generation of power. So that is about the diversity factor. Next is plant capacity factor. It is the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. So we can write actual energy produced divided by maximum demand that could have been produced, or we can write average demand into time period divided by planned capacity into time period. So actual energy produced is average demand into time period, and also maximum demand produced is planned capacity into time period. So we can write average demand divided by planned capacity. And if the considered period is 1 year, then annual plant capacity factor is equal to annual kilowatt hour output divided by plant capacity into 8760. The plant capacity factor is an indication of reserve capacity of the plant. A power station is so designed that it has some reserve capacity for meeting the increased load demand in future. Therefore, the installed capacity of the plant is always somewhat greater than the maximum demand on the plant. So we can write reserve capacity is equal to planned capacity minus maximum demand. So here the difference between the load factor and planned capacity factor is an indication of reserve capacity. If the maximum demand on the plant is equal to the planned capacity, then load factor and planned capacity factor will have the same value. In such a case, the plant will have no reserve capacity because maximum demand is equal to the planned capacity. Then we have load factor and also the planned capacity factor will have the same value. So that is about the planned capacity factor. Next is planned use factor. It is the ratio of kilowatt hour generated to the product of plant capacity and the number of hours for which the plant was in operation. That is, it is the ratio of station output in kilowatt hour to the product of plant capacity and hours of use. Next one is units generated per annum. So it is required to find the kilowatt hour generated per annum from the maximum demand and load factor. So how will you find the units generated per annum from the load factor and maximum demand? So we have load factor is equal to average load. average load divided by maximum demand. Then we can write average load is equal to maximum demand into load factor. So units generated is equal to units generated per annum is equal to, it will be average load into the time period. So units generated per annum is equal to average load in kilowatt into hours in a year. So average load is, we can write maximum demand into load factor into hours in a year is 8760. So this is the relationship between units generated and load factor and maximum demand. So units generated is equal to average load into hours in a year or maximum demand into load factor into 8760. Next is load duration curve. When the load elements of a load curve are arranged in the order of descending magnitudes, the curve thus obtained is called load duration curve. So what is load curve? It is the curve showing the variation of load on the power station with respect to time. So when the load elements of the load curve are arranged in the order of descending magnitudes, and then we plot the curve, is called the load duration curve. So that is about the important terms and factors in power systems.